Welcome to this video on microservices, an architectural approach that has been transforming the world of software development today. In this comprehensive guide, we're going to explore the concept of microservices, its benefits, implementation strategies, and best practices. Whether you're a developer, an architect, or simply someone that's curious to know what the world of software development holds, this video right here is for you. If you're new to our channel, don't forget to hit the subscribe button and join our tech-savvy community as we drop new videos every day so as to be able to keep you up to date with the latest technology and information. Now let's take the time to actually appreciate how the world of technology has transformed. Remember the days when software applications were massive monolithic based? Oh my god, we used to have these colossal systems that were difficult to maintain, update and scale. It was like trying to tame a wild dinosaur. But fear not, because in this age of innovation, we've found a better way: microservices. These tiny powerful building blocks have completely changed the game today. Think of them as superheroes of the software world, each with its unique ability, working together to create a remarkable application. So how do we actually get here? Well, let's embark on a journey through time and technology. Software applications used to resemble giant fortresses, where components were tightly coupled, making even the smallest change a monumental task, and any hiccup in a part could bring the entire structure crashing down. But then, brilliant minds and creative thinkers started to question this approach. They asked themselves, what if we break down these monoliths into smaller manageable pieces? And thus, the era of microservices began. Microservices emerged as a way to tackle the limitations of monolithic architectures. It's like breaking free from shackles and embracing a more flexible, scalable, and efficient approach. With microservices, we can now develop softwares in a modular and independent manner, like assembling a puzzle where each piece contributes to the grand picture. And let me tell you, it's been an exciting journey so far. Companies across industries have adopted microservices, revolutionizing how they build and develop software. From e-commerce giants handling massive transaction volumes to social media platforms with millions of users, microservices have become the go-to strategy. So my friends, buckle up and get ready to go on an adventure into the world of microservices. We'll explore the benefits, implementation strategies, and best practices that have made the architectural approach a game changer. And who knows, by the end of this video, you might unleash the superhero within you to build amazing software applications. Make sure you're subscribed to our channel so you don't miss out on any future episodes, as we're constantly releasing new videos to keep you updated. Before we start talking about the benefits of microservices, let's take a moment to understand what exactly microservices are. What are microservices? Microservices are an architectural style where applications are built as a collection of small, loosely coupled, and independently deployable services. Each microservice represents a specific business capability and can be deployed, developed, and scaled independently, offering greater flexibility and agility. A microservice can be compared to a modular building block or a Lego brick. Just as a Lego brick can be individually assembled and combined with other bricks to create various structures, a microservice is a contained unit that can be independently developed, deployed, and scaled. Like Lego bricks, microservices can be combined and orchestrated to build complex and flexible software systems. Each microservice has its own specific functionality and can be easily replaced, modified, or added without affecting the entire system. I am sure you must be wondering why they are such a game changer. Let's look into that. Microservices offer developers the freedom to choose the best tools, technologies, and languages for each individual service. This flexibility enables teams to adapt and experiment, leading to a faster innovation and improved time to market. Gone are those days where we're tied to a single technology stack. Microservices empower developers to select the right tools for the job. They allow applications to scale horizontally by independently scaling individual services based on their specific needs. This granular scalability doesn't only optimize resource utilization, but also provides fault isolation. If one service experiences a failure, it won't bring the entire system crashing down. Instead, other services continue to function independently, ensuring fault tolerance and improved system reliance. In a microservice architecture, the development team can work on different services simultaneously, leveraging their specialized skills in different areas. This parallel development approach enhances productivity, promotes autonomy, and encourages a culture of ownership. Teams can focus on specific business capabilities without stepping on each other's toes, fostering collaboration and efficient delivery. The modular nature of microservices enables rapid deployment and development cycles. With each service being self-contained and independently deployable, the developers can release updates to new features without impacting the entire application. This flexibility allows the organization to respond swiftly to market demands, staying ahead of the competitors. Remember how in a monolithic architecture, a failure in one component can cause the entire system to crash? Microservices provide fault isolation, meaning that if a particular service fails, it won't bring down the entire application. This isolation makes troubleshooting and debugging easier, reducing downtime and improving overall system stability. So there you have it, the numerous benefits that microservices bring to the table. But as with any other architectural approach, it's essential to understand how to design and implement microservices effectively. Conceptually, it sounds wonderful, but let's see what exactly we need to consider when designing microservices. When designing microservices, one of the essential principles to keep in mind is modularity. Each microservice should represent a specific business capability or functionality, allowing for the independent development, deployment, and scalability of that service. By breaking down the system into smaller, well-defined services, we enable the team to work in parallel and ensure that the right level of granularity is met. You also need to make sure that each microservice is bounded by context. Bounded by context are distinct areas of an application that have their own modules, building roles, and data. When designing microservices, it's crucial to identify and define this bounded context. This helps determine the boundaries between services and ensures that each service has a clear responsibility, minimizing independencies and facilitating independent development. Furthermore, each microservice should be autonomous, meaning it can function independently and has its own data store. Autonomy allows the team to make changes to a specific service without affecting others, enabling faster iteration and reducing the risk of unintended consequences. Inter-service communication plays a vital role in any microservice architecture. When services need to interact, there are basically two primary communication patterns: synchronous and asynchronous. Synchronous communication involves direct request-response interactions, while asynchronous communications relies on event-driven messages. Choosing the appropriate communication pattern depends on factors such as performance, scalability, and fault-tolerant request. However, microservices present unique challenges when it comes to data management. One crucial decision is selecting the appropriate database strategy for each service. Options include dedicated database per service, shared databases, or polyglot persistence. The choice depends on factors such as database consistency requirements, database access patterns, and the need for scalability. So maintaining database consistency across microservices can be challenging due to the distributed nature. There are basically two principal approaches: maintaining strong consistency or embracing eventual consistency. Each approach has its trade-offs, and the decision depends on a specific business requirement of the application. Designing and implementing microservices can be an exciting yet complex endeavor as well. In the next segment, we're going to continue to explore microservices in action, diving into topics such as microservice orchestration, scaling, resilience, and observability. But for now, let's take some time to actually process what we've learned so far. Would you rather have a microservice or a monolithic application? Before we continue, drop your comments in the comment section and let's make this even more educative and fun. In the following segment, we're going to look into coordination and communication aspects that play a vital role in the microservice architecture. Coordination in this context refers to how the different services work together and communicate with each other effectively. To achieve this, various approaches to microservice orchestration are utilized. which can be the centralized or even the decentralized approach. Decentralized orchestration involves a central component managing the interaction between the services, while the decentralized approach relies on services to communicate directly with each other. The centralized orchestration tool, like Kubernetes, helps to manage the coordination of the microservice deployment and scaling, while the decentralized orchestration event-driven messaging system like Apache Kafka enables direct communication between the services. Within microservice architectures, there are essential considerations when it comes to scaling individual services. Horizontal scaling, which involves adding more instances to the service to enable and make sure that it handles the increase in demand, is a popular strategy. Load balancing techniques are implemented to distribute incoming requests evenly across multiple servers. Auto-scaling mechanisms are also employed to automatically adjust the number of services or instances based on predefined credentials, such as, for example, CPU usage or even request rates. Another critical aspect of microservice architectures is fault tolerance and resilience. Since failures can occur, it's important to implement mechanisms that ensure that the system remains operational even in challenging scenarios. Fault-tolerant mechanisms such as redundancy or error handling are employed to handle failure gracefully and minimize the service disruption. Additionally, self-healing strategies are implemented to automatically detect and recover from failures, reducing manual intervention and improving system reliability. Monitoring and observability in a microservice architecture poses unique challenges due to the distributed nature of the services. Comprehensive logging, monitoring, and tracing practices are crucial for gaining visibility into the system's behavior. Distributed tracing systems provide insights into how requests flow through the different services, aiding in troubleshooting and performance optimization. Centralized logging enables the aggregation and analysis of logs from multiple services, simplifying debugging and auditing processes. Additionally, service health checks and metrics help to monitor the overall system performance, enabling proactive detection of issues and facilitating capacity planning. Testing is a critical aspect of ensuring quality and reliability for all microservice-based systems. Various testing strategies are employed throughout the development lifecycle. Unit testing validates the behavior of individual services in isolation. End-to-end testing verifies the correct interaction between multiple services, ensuring that the system functions as a whole. Contract testing validates the compatibility between the services by defining and verifying the agreed-upon contract they adhere to. Additionally, chaos engineering introduces controlled failure and distribution to test the system resilience, uncovering vulnerabilities and validating effectiveness of the fault-tolerant mechanism. In the world of microservices, ensuring the security of the system and interaction between the services is of utmost importance. Authentication and authorization mechanisms, secure inter-service communication, and network security best practices are essential to consider. By implementing robust security measures, you can protect your microservice ecosystem from unauthorized access and potential vulnerabilities. Additionally, data encryption and protection should be implemented to safeguard your sensitive information, ensuring the confidentiality and integrity of your data. Microservice architectures align seamlessly with DevOps practices and continuous delivery pipelines. The modular nature of microservices allows the independent deployment and scalability, making it easier to incorporate DevOps practices such as continuous integration and continuous deployment. Infrastructure as a code and containerization enables effective management and deployment of microservices. Monitoring and automation plays a crucial role in maintaining the health and the performance of the microservices ecosystem, allowing for a quick identification and resolution of issues. Microservices have gained significant traction across the various industries, showcasing their benefits and impacts. Industries such as e-commerce, finance, healthcare, and more have witnessed the transformational power of microservices. By embracing microservices, organizations experience increased flexibility, accelerated time to market, improved scalability, and enhanced fault tolerance. As technology continues to evolve, future trends in microservices include serverless microservices, edge location computing, and the interaction of microservices with emerging technology like AI and blockchain. This trend addresses scalability and also makes sure that new possibilities for effective and innovative software development are brought to light. As we approach the end of this microservice journey, it becomes evident that this architectural approach has revolutionized the way of building software. By embracing microservices, organizations gain greater agility, scalability, resilience for all of their software systems. However, it's important to remember that the world of technology is ever evolving, and there are always new possibilities and challenges on the horizon. As we continue on this exciting path, it's crucial for you to stay curious and explore new emerging trends as well as adapt to the evolving landscape of these microservices. Thank you for joining us on this adventure through microservices. If you found this video insightful, don't forget to like, share, and subscribe to our channel. If you have any comments or questions, feel free to leave them in the comment section. Keep exploring and embracing the power of microservices as we navigate the ever-evolving world of software architecture. Until next time, stay grinding and stay hustling. See you. Bye-bye.